Section 2.2, Trigonometric functions of non-acute angles. So in this section, the first thing we're going to talk about is reference angles. And a reference angle for an angle theta is the positive acute angle made by the terminal side of an angle theta and the x-axis. Reference angles are always less than 90 degrees. Now, in that definition, there are a lot of things that you need to understand. First of all, a reference angle is positive and it is acute, less than 90 degrees, and it's always made with its terminal side of the angle theta and the x-axis. So terminal side of angle theta and the x-axis. So there's a lot of things going on here. So let's look at the first problem. It says find the reference angle for 215 degrees. Well, if we have an x and y axis and we draw this angle 215. 215 is a little more than 180. So here is your 215 degree angle. Now, the reference angle which we call theta prime, your reference angle has to be positive. It has to be less than 90 degrees, and it has to be made with the terminal side of your angle given and the x-axis. So the reference angle is going to be this angle here. It has to be made with the x-axis, and it has to be made with the terminal side. So the angle for the terminal side and the x-axis, it's going to be positive and it's going to be less than 90 degrees. So we are looking for this angle here. So we know that from here to here is 180 degrees. So if we take 215 and we minus 180 degrees, we're going to get 35 degrees. So the reference angle for 215 is 35 degrees. Alright, so let's try this one. So here we have x and y and negative 218 degrees. Remember, negative angles are going to go clockwise. So negative 280, we're going to go past negative 180, or 218. We're going to go past negative 180. And then this is going to be negative 218. So theta prime, the reference angle, is going to be, again, it has to be made with the x-axis and the terminal side of the angle. So it's going to be this angle here. So negative 218, and it's going to be, that reference angle has to be positive. So we have, if we have negative 218, but we want the positive angle from here to here. So if we just do 218 minus 180, that's going to give us 38 degrees. So the reference angle for negative 218 degrees is going to be this angle here, which is going to be 38 degrees. Okay, for angles bigger or smaller than 360, to find the reference angle, you're going to have to use coterminal angles. So for angles bigger or smaller than 360, you're going to have to use coterminal angles. So the first thing we need to do is we need to get 1500. We need to find the coterminal angle for 1500. So 1500, let's do minus 360. So let's just go ahead and start 1500 in the calculator. Minus 360 is going to give us to 1140, so let's minus 360 again. And that's going to be 780, so let's minus 360 again. That's going to be 420, so let's minus 360 again. And that's going to get us to 60 degrees. So if we keep minusing the 360 until we actually get into an angle that we know what it's going to be within the 360 degrees. So if we take 1500 and we minus 360 4 times, that takes us to 60 degrees. So now we can draw our reference angle, and of course 1500 is going to take us 4 rotations, but we just need 60 degrees here. That's not 60. Let's go here. So this is going to be 60 degrees. Alright, so theta prime is going to be, this is going to be 1500 really, because we're doing 4 rotations, 360 around and around. So 1500, but the reference angle is going to be that 60 degree angle. So the coterminal angle and the reference angle is actually going to be that 60 degrees because it has to be made with the terminal side and the x-axis, the terminal side and the x-axis. So actually the coterminal angle is the reference angle this time. Alright, so what if we're at negative 345 degrees? Negative 345, that's going to take us around and a little bit more than 360. Around and a little bit more than 360. So let's do 345 minus 360. And that's going to give us 15 degrees. So this theta prime is going to be 15 degrees. So what I did is I did 345, well technically plus 360. Negative 345 plus 360 is going to get us to 15 degrees. So the reference angle is going to be 15 degrees. Alright, if we're at 1050, I don't know where that is on this one, but I can do the coterminal angles. 1050 minus 360 is going to get me to 690, so I need to go again minus 360. That's going to get me to 330. So 1050 is actually a whole 2 rotations plus another 330. So it's going to be about right here. Now, this is what you have to be careful with. Remember that your reference angle has to be positive and it has to be made with the x-axis. So we're actually looking for this angle right here. Because remember, your reference angle has to be made with the x-axis and the terminal side of your angle, and it has to be positive and it has to be less than 90 degrees. So a lot of things for reference angles. So we're looking for this angle here. So what I'm going to do is I'm going to do 360 minus 330, and that's going to be 30 degrees. So my reference angle is going to be 30 degrees. Alright, special angles, and this is where reference angles can help us. We talked about those special right triangles, the 30, 60, 90, and that's where this is going to come into play. If a reference angle is a special angle, then you can find the exact, remember use radicals, no decimals, value of the trig functions of the angle. A smart trig class does come into play here. It is a way to remember the signs of the trig functions in the 4 quadrants. Alright, so find the exact values for the 6 trig functions. Find the exact values for the 6 trig functions. So the first thing I want to do is I want to find the sides of this angle. So watch this. If we're talking about 240 degrees, 240 degrees is going to be about right here. And remember, this is 240. And remember, it's going to make a right triangle. Well, I need to know what this angle theta is going to be. I need to know what this angle right here is going to be. So if you remember, that's actually going to be a reference angle. So theta prime is going to be the angle made for the 180 x-axis and the 240, the terminal side. So let's do 240 minus 180, and we're going to get 60 degrees. 60 degrees. So we know that this is a 30, 60, 90 triangle. This is a 30, 60, 90 triangle. Well, we also know that in a 30, 60, 90, the hypotenuse and the side opposite and the side adjacent. So for a 30, 60, 90, we know that the short side is 1, and then the the medium side is the square root of 3, and the long side is 2. So we can find sine of 240 is going to be the same as sine of 60. So you can see how reference angles can help us find an unknown angle. So sine of 240 degrees is going to be the exact same as sine of 60 degrees. So sine of 240 is going to be opposite over hypotenuse, so that's going to be square root of 3 over 2. Cosine of 240 is going to be adjacent over hypotenuse, so adjacent is going to be 1 over 2, so 1/2. And then tangent of 240 is going to be opposite over adjacent, which of course is just going to be square root of 3. And so once we know these, we can also find the inverse. So the inverse of sine is cosecant of 240 degrees is going to be 2 over the square root of 3, and of course we need to rationalize that, so that's going to be 2 square roots of 3 over 3. Cosine, not cosine, but secant, its inverse, secant of 240 degrees is going to be 2 over 1, or just 2. And then cotangent of 240 degrees is going to be 1 over the square root of 3, and then when we rationalize, we'll get the square root of 3 over 3. So again, if you have an angle that you're not sure of, find its reference angle. Find the coterminal, find the reference angle, and then if it's a special angle, then you can use your special right triangles. Alright, so for a negative 150, negative 150 is going to take us about to right there. So the reference angle for negative 150 is going to be this angle here, that angle there. So that's going to be 30 degrees. So your reference angle is going to be 30 degrees. And I know that because the distance from here to here, from the 150 to the 180, is just a difference of 30 degrees. So now what I have is a 30, 60, 90 right triangle. A 30, 60, 90 right triangle, 30, 60, 90, and we're going off of this 30 degree angle. We're going off of this 30 degree angle, so we know we have again 1, 2, square root of 3. So we can find sine of negative 150, basically, sine of negative 150, which is going to be the same as sine of 30 degrees. So sine of 30 degrees is going to be opposite over hypotenuse, which is going to be 1/2. Cosine of negative 150 is going to be adjacent over hypotenuse, so that's going to be square root of 3 over 2. And then tangent of negative 150, tangent of negative 150 is going to be opposite over adjacent, so we're going to have 1 over the square root of 3, which is going to be the square root of 3 over 3. Now if we do the inverses, so we have cosecant. Cosecant of 150 is going to be 2 over 1, which is just 2. Secant of negative 150 is going to be 2 over the square root of 3, and then rationalize, we have 2 square roots of 3 over 3. And then cotangent of negative 150 is going to be square root of 3 over 1, which is the square root of 3. Now, remember, and I did forget, but remember that the signs of these quadrants, because we are talking about angles and quadrants, can be remembered for a smart trig class, and we talked about that in the previous chapter. So if we're in quadrant 3 for 240 degrees, we're in quadrant 3. So remember, a smart trig class. So the only thing that's positive in quadrant 3 is tangent and its inverse, which is cotangent. So sine is going to be negative and cosecant is going to be negative. Cosine is going to be negative and secant is going to be negative. So don't forget those signs like I did. Okay, for negative 150, again, we are in quadrant 3. So again, your sine is going to be negative 50 and your cosecant. And then your cosine is going to be negative 150 and your secant. And then tangent is going to be positive along with cotangent. Alright, so find the exact values for the 6 trig functions for each angle. So let's do this again. Alright. So we're talking about negative 390 degrees. So I know that that's a full rotation and a little bit more. So we can do, so this is going to be negative 390. So let's see if we can find this reference angle here. So if we do 390 minus 360, that's going to be 30 degrees. So that reference angle is going to be 30 degrees. So we can go off of our 30, 60, 90 again. And so we have 1, 2, square root of 3. Alright, so sine of negative 390. And again, we are in quadrant 4, so the only thing positive in quadrant 4 is cosine and its reciprocal. So sine is going to be negative, and the reference angle is 30, so it's going to be opposite over hypotenuse, so that's going to be 1/2. And then cosine of negative 390. Again, we are in quadrant 4, so this one's going to be positive. So cosine of 30 degrees basically is adjacent over hypotenuse. And you'll do these enough to where this will be pretty much memory. And there is actually a chart in your book. If you want to memorize them, you can. Tangent of basically 30 degrees is going to be opposite over adjacent, which is going to be 1 square root of 3, which is going to be the square root of 3 over 3. And then cosecant, of course, and this is negative. Cosecant of negative 390 is going to be the reciprocal, so that's going to be negative 2. Secant of negative 390 is going to be 2 over the square root of 3, but if we rationalize, it's going to be 2 radical 3 over 3. And then cotangent of negative 390 is going to be the square root of 3, and it is negative. And again, we're in quadrant 4, so a Smart Trig class will help you with those signs. Okay, 1305. Let's see how many times around that is. So if we do 1305 minus 360, that's going to get us to 945, so let's minus 360 again. And that's going to get us to 580. So let's minus 360 again. And that's going to get us to 225. So that's going to be 3 rotations. So we have 360, 360, and we said that was going to get us to what? 225. So 225, not quite that much. Alright, so we are looking for this reference angle here. So 180, or 225 minus 180. That's going to get us to 45 degrees. So our reference angle is 45 degrees, so we can use our special right triangle, 1 to 1 to square root of 2. to do our 6 trig functions. So, and we are in quadrant 3, so tangent and cotangent are the only thing positive. So sine of 1305. Sine of 1305 is going to be opposite over hypotenuse, which is going to be 1 over the square root of 2, but we know we can't do that, so it's going to be square root of 2 over 2. And it is going to be negative. Cosine of 1305 is going to be adjacent over hypotenuse, or it's going to be the same, so negative square root of 2 over 2. And then tangent is going to be positive, because we're in quadrant 3, so tangent is just going to be 1, opposite over adjacent. And then it's reciprocals, so we have cosecant of 1305 is going to be negative square root of 2. Secant of 1305 is going to be negative, same thing, square root of 2. And then cotangent of 1305 is going to be 1 again, positive. So again, if you have something bigger than 360, you're going to have to use your co-functions, and you're also going to have to use your reference angles. Okay, so finding angles. Find all values of theta if theta is on the interval of 0 to 360 that have the given function value. So basically what we're doing is we're going backwards. Find all values of theta if we're on 360 degrees. So what we need to do is we need to figure out where are we. And I know that I have seen square root of 3 over 2 before, and I know that has to do with my 30, 60, 90 triangle. So if I do 30, 60, 90, and I have 1, 2, square root of 3. Okay, cosine of theta, and theta is what we're looking for, alright? Theta is what we're looking for. So, if we know that cosine is adjacent over hypotenuse, we have to look at what angle has a square root of 3 as an adjacent leg, and then of course the hypotenuse is 2. So we're looking at 30 degrees. Do you see how I did that? Cosine of theta. Cosine is adjacent over hypotenuse. So we have to look for an angle that has an adjacent leg of square root of 3 and of course the hypotenuse of 2. So that's square root of 3 adjacent and hypotenuse. So that's going to be our 30 degree angle. So theta is 30, but it says find all values of theta. So look at this. If we go on our 360 degree unit circle, cosine is positive, so this is where a smart trig class comes into play. A smart trig class. So everything in quadrant 1 is positive. So we know that 30 degrees is good. But we also are looking at cosine, so we're also looking at a reference angle down here of 30 degrees. So if we look at that reference angle, we can also get 360 minus 30, so our reference angle is 30 degrees, but the actual angle is 330, because you can do 360, this angle here, 360 minus 30 degrees of your reference angle. So there is another one that has a cosine of 30 degrees that's positive, and we know that because of those reference angles. So make sure you're aware of all positive cosines that have square root of 3 over 2, have a value of square root of 3 over 2, and that's going to be your 30 degrees and another angle in quadrant 3 that has a reference angle of 30 degrees, which is 330. Alright, so let's try this again. Secant is negative. Okay, so if secant is negative, going off of a smart trig class, if secant is negative, secant is the inverse of cosine. Well, we know that we cannot be in quadrant 1 because everything's positive. Well, we have a negative value here. And we know that in quadrant 4, secant and cosine are positive, so we know that we can't be in quadrant 4. Alright, so we know that we're in quadrant 1 and 2, so now we got to figure out what our angles are going to be. So if we're at negative square root of 2, we know that our special right triangle that has a square root of 2 in it is our 45, 45, 90. Our 45, 45, 90. Okay, and secant is hypotenuse over adjacent. Hypotenuse over adjacent. So if we're looking for an angle that has hypotenuse over adjacent, we're talking about a 45-degree angle. So we're looking at 45 degrees here, and we're looking at 45 degrees here. So the reference angle is going to be 45 degrees. But that's not theta. That's just our reference angle, okay? In the first problem, it just so happened that our reference angle was theta because we were in the correct quadrant. But here, 45 degrees is in quadrant 1, and so we know that we can't be in quadrant 1 because our value is negative. So instead we have to use these reference angles. So let's do 180 minus 45 degrees. 180 minus 45 degrees is going to be 135. So that's going to be one of those angles, 135. And then let's find the one in quadrant 2. The one in quadrant 2, so we'll do 180 plus 45, and that's going to be 225 degrees. Okay, so that's how you're going to find values of theta. You're actually looking for your angles. And what's the difference? Well, in the previous slide, they gave us the angle and we were looking for the values. This time they're giving us the values and we're looking for the angle. So you kind of have to work backwards, and signs do come into play here. Alright, so what I would like you to do is I'd like you to try these problems on page 63 through 66. If you have problems, look back in the video, look in your book, or bring them into class and we'll work them in class.